Hi, my name is Felipe de Jesus Martinez Tapia, and I'm going to present the work Simulation of Higgs-Traun Process with the Higgs decaying to a pair of gammas collisions for the FCC-EE project with the FCC-Analyses program. The objective of this work is to obtain the transfer momentum of photons that decays from the Higgs boson when the production mechanism is the Higgs-Traun process. As a part of the introduction, the FCC-EE aims to study the Higgs, Z, and W bosons, the top quark, and other standard model particles, and to investigate the dynamics of electroweak symmetry breaking and Higgs boson self-coupling. The two main mechanisms of Higgs boson production are the Higgs-Traun process, and this consists when we have an electron and a positron. This is the case into a Z boson, and the final state is a Z and Higgs boson. And the other is a W. This occurs when we have an electron and a positron. This derives into a pair of W bosons, and the fusion generates a final state of a pair of neutrinos and a Higgs boson. For the channel of interest, Higgs decaying to a pair of gammas of the Higgs-Traun production, the relative uncertainty for a center of mass equal to 240 GeV at a luminosity equal to 5 attobar inverse is more or less than 9%. And as we can see, when we change the center of mass and the luminosity block, and we change the Higgs production to the WW fusion, the relative uncertainty is greater. Based on the analysis of the data collected by Delphi at LEP2 detectors with T-center of masses, the process to consider as background to the process of this work are when we have an electron-positron collision, we finally state an electron and positron, a pair of gammas, a pair of taus, and a pair of neutrinos and photons. For this work, the EDM program was used to the Monte Carlo MC particle, and this program used Podio tools to generate the digitation and raw data. And the reconstruction analysis uses the program Delphi. With this program, we generate the data, and this is some example of databases, and this is contained in the IDEA Spring 2021 database. Subsequently, these data were treated with the FCC-Analyses framework, which are the analyzers and filters that contain the configuration of the necessary parameters to allow merging process, normalize to recurrent luminosity, and plot the signal with different backgrounds. For this work, the necessary addresses and libraries were created while making a local copy of the GitHub container of the FCC-Analyses framework into an LX Plus session. And the following steps were followed. Finally, the analyzer of the Higgs-Traun process with Higgs decaying to a pair of gammas was used and modified for this process, in which the reconstruction of the photons that the case of this process is considered and then a selection is made. As a part of the results for the simulated processes, 1 million simulations were performed for the process of the Higgs-Traun, Higgs generation, and Higgs decaying to a pair of gammas with a center of mass equal to 240 GeV with a luminosity of 5 attobar inverse. And as can be seen from the graph, the peak in the number of events related to the transverse momentum of the photons is at the value of 2 GeV. And the largest number of events is in the interval from 2 to 30 GeV, but the Higgs boson has a mass of 125 GeV. It is expected that on average the photons has a mass of 62.5 GeV. So a code is made at 30 GeV photons that come from other processes, and the result in this graph. As a conclusion, was the transfer momentum of the photons from the Higgs boson decay in the Higgs-Traun process has been obtained. The next step of this project is to compare it with the predominant backgrounds in order to maximize the sensitivity in this channel and help establish the characteristics of the detectors. Well, this is all from me. Thanks so much, and this is my reference.